Okay, guys, so one of the big things from section 5.3 day 2 here is I'm going to introduce another diagram. There's the two-way table and the Venn diagram. Those are ways to keep track of probabilities and make it so you won't make as many mistakes. It's a helpful organizational tool. Let's just put it that way. Now, the formulas are also helpful organizational tools, and some questions can be answered using, like, for example, a two-way table or just putting numbers into the formulas. Well, I got one more diagram, and I'm going to use this nice, easy example. I'm going to toss two coins. What's the probability that I get tails and tails again? Now, notice, as opposed to the last couple of days, I'm not using the word or, I'm using the word and. So they have to both happen. I get tails on the first one, and I also get tails on the second one. It's kind of like the intersection of two events, right? So in the Venn diagram, it's where the two circles intersect. Okay, write out the sample space and probability model. Well, there's four things that could happen, right? For the first event, there's two heads or tails. For the second event, there's two options, heads or tails, and 2 times 2 is 4, and here they are. I could get heads and heads, or heads and tails, or tails and heads, or tails and tails. Since there are 4 different possibilities, and every one of them is equally likely, the probability for each one of them is 1/4. So that's my complete probability model. If you are asked to verify if a probability model is legit, you have to check two things. Are all of them between 0 and 1? Yes. And do they add up to 1? Yes. So the probability of tails and tails is right there. It's 1/4. Now, couldn't you have got that by saying 1/2 times 1/2? Okay, here we go. You could also make a tree diagram of this sequence of events in order to keep track of the probabilities. Here's what the tree diagram looks like. There's your starting place. Here is your first set of possibilities. I could get heads or tails on the first toss. So what are my probabilities? I write them along the way. There's a 0.5 right here and a 0.5 right there. I put the probabilities on the little branches of the tree diagram. Now, this one is the possibility of getting heads on the first flip. So what could happen on the second flip? I could get heads or tails after having gotten heads there. And then here, I could get heads or tails after having tails come up on the first. So since these are still 1/2, I'm going to put the 0.5s on each one of these branches as well. And so to get the probability of both things happening, you travel along the tree diagram and you multiply the probabilities along the way to get your answer. Okay, so on this one, the probability of heads and heads is 0.5 times 0.5. 1/2 times 1/2, it's 1/4. Okay, so 0.25. Traveling along heads and then tails. This is the probability of heads and tails. Well, that's also 1/2 times 1/2, so this will be 0.25. These are easy because they're all the same and they're independent. So this would represent the probability of tails and heads. That's going to be 0.25. And this one is the probability of tails and tails. That's 0.25. Okay, now look, just like these all have to add up to 1 at the end of the tree diagram, these all have to add up to 1. So I'm going to put a fancy little, add all these up, and my sample space equals 1. Okay, so where the probability of tails and tails, instead of having to write everything out in a chart, I can say that it is 1/2 for that tail, and then another 1/2 for this tail. It's equal to 1/4. Now, I've got to point out something to you. These are straight up probabilities. That's just the probability of heads. That's the probability of tails. Now, because flipping a coin a second time is an independent thing, it doesn't change when we get here. But I want you to know that the second tier of probabilities are conditional probabilities. Now, they will change when we have events that are not independent. So this is really the probability that I get tails given that I got tails in the first place. So I want to sneak that in here so you see it. This is the probability that I get tails given that I already had tails in the first place. And that's 0.25 because they're independent. Okay? That's going to be a big deal in a little bit. Just multiply the two probabilities together is another option for how you could find the probability of tails and tails. You see the structure of what's going on with my notes here. I'm setting you up 3 different ways. Hey, I could write out everything in a sample space, fill in all the probabilities, and then just take the probability from my chart. Or I could do a tree diagram where I multiply along the way. Or the third option, I could just multiply the two probabilities together because they're independent. The probability of tails and tails is it's the probability of tails times the probability of tails. So 1/2 times 1/2 is 1/4. Okay, the general multiplication rule for probability. It goes like this. The probability that two events both occur, that's not or, that's and. So I'm going to put a big fat and out here. The probability that A and B both happen, probability of A and B is found by the probability of A and B is equal to, you take the probability of A and you multiply it times the probability of B given that A happened. Now in this case when we're flipping coins, the fact that A happened doesn't affect probability of B. That's why we got 2 1/2s here and we have 2 1/2s here. Leo's he's getting comfy. That's a brand new dog pillow for him, by the way, and he just shoved his nose in the little corner. That means he likes it. Or he's going to start sneezing. Anyway, now, if A and B are independent, then we learn that probability of B given A, you know that one right there, is just the probability of B. So I'm sort of giving you two formulas here. So definition, if A and B are independent events, then the formula A and B can just be the probability of A times the probability of B. I don't need the conditional part. Now you have to be able to show that they're independent first before you can do that. And so that's a really subtle little difference going on right there. Okay, let's go to the next page and the next video.